ideas we've learnt in Year 8 Maths about linear graphs. So let's do this first question. It asks us whether the statements are true or false, and we're told the table below represents a linear pattern. Now for a linear, what we need is each y value is connected to the next one by the same adding or subtracting, as in you're going up by the same amount or going down by the same amount, because of the word line in linear. So linear patterns can be represented by straight lines. Now if you think about a straight line, as you go across horizontally, you go up by the same relative amount vertically. So all we have to do is check whether it does that, whether it goes up or down by the same amount. We look at is between -2 to 2, all of the whole numbers there. Thinking about this one to this one, well, you're going from -4 to -3, you're adding 1. From -3 to -1, you're actually adding 2. So now we're actually going up by a different amount. Here we're adding 2, here we're adding 1. So because it's not always the same amount you're changing by, then you have not a linear pattern. So if this says the table below represents a linear pattern, that is false. False, it is not linear. Next, we've got another one, and we're told it's a linear pattern. Let's just see if that's true or false. If you think about the y values, so we've got x values, again, just -2 to 2, all the whole numbers there. So as x goes up by 1, y goes up by, you're adding 2, right? X goes up by 1, y goes up by 2, very good. You're adding 2 again, adding 2 again. So this is true. We have ourselves a linear pattern. Cool. All right. For this next one, we're asked to complete a table of values using a rule given. Our rule is y equals x take 3. So it doesn't really matter where you start. Maybe you'd want to start with this first one when x is -3. What you need to do is take this and substitute it in here for x here. So replacing x with -3. So if we do that, we have y equals -3 instead of x, take 3. You have -3 and you take away 3, you now have -6. It's becoming more negative, right? So in this box, we put -6. The next one, you again just substitute. I like to substitute using brackets. Helps me keep track of things like negative signs. -2, take 3, that's -5. So in here goes -5. Next one, just drawing a little separator line. So instead of x, we've got -1. Substituting that in. So -1 take 3 is -4. Let's just do another. Substituting in for x 0. So we've got 0 take 3. Well, 0 take 3, you're left with just -3, -3. Now you can probably realize, kind of like we were talking about before, you're just going up by the same amount, aren't you? Just going up by 1 each time. So rather than doing another substitution, I could just, well, after realizing that, I'm just going to go, all right, well, the next number up 1 from -3 is -2. From there to be -1, and then it'd be 0. If you can notice those kind of patterns, you can save yourself a bit of time, especially with a question like this where you're filling in a table of values. Let's do this other one with a different rule. Our rule now is y equals 4x. If you think about that, well, we just do the same process, right? So replace x with first x value is -3 again. So we've got 4, then brackets -3. If you've got a number next to another one with brackets, that's implied multiplication, timesing, right? So we've got 4 times -3. We've got a positive times a negative, so that's negative. 4 times 3, that's 12. So in this box, we get -12. Let's do the next one. Y equals 4 bracket -2, substituting in for x -2. So again, we're going to get a negative. 4 times -2, and 4 times 2 is 8. We get -8. Let's do another one. Y equals 4 bracket -1, and you get, well, 4 times -1 is just -4. Yeah. Now you might realize, okay, well, if we look at this pattern, it's just going up by 4 each time. So this one is going to be 0. This one is going to be 4. This will be 8. This will be 12. Cool. Done deal. All right. Let's do another example. This one, we're told a rule, told to find its table of values. Look at this. let's have a look. So they're all of them, it appears, have as the on the x phase, it's just -2, -1, 0, 1, 2, all those whole numbers. Probably what I would do first is 0 is a really easy number to work with, right? If I substitute in 0 for x, then that 3 is just going to go away, right? Anything multiplied by 0 is 0. So we get y equals 4. So we've got to have 4 in this box. So we've got two options there. So we know it's not this one, not this one, not this one. Now we just need to check some other ones and see what else. So both of B and E have 7 in the next box, but then for 2, one's got 10, one's got 11. So why don't we just substitute in 2? Y equals 3, and then brackets 2 plus 4. So 3 times 2 is 6, plus 4 is 10. So it must be this one, and it can't be that one because of this. So we're left with B. Easy peasy, hopefully. Okay, bit of a harder one. We're told to make a table of values and then plot a graph for each of the following relations. So we're only given one. We're given y equals -2x plus 3. So we can just kind of use those skills from before. What I might do is I might do 0 again first. If I substitute in 0 for that, y equals -2 in brackets 0 plus 3, then you get 3, right? Because anything times 0 is 0. So we've got 1 point when x is 0, y is 3. This is like a coordinate, right? So we normally write the x value first, then a comma, and then 3, all of that in brackets. So the x coordinate tells us how far to go from the origin, this center point, there. We want to go 0 units left or right, or horizontally, but we want to go 3 units up because the y value is 3. So we're going to end up 1, 2, 3, right there. So we've got 1 point there. Next one, let's go y equals, we'll sub in 2, so -2 times 1 plus 3. -2 times 1 is just -2. Plus 3, well, you're going to go -2, -1, 0, 1, right? And end up with +1. So our other point, we've got a point at 1, 1. So x, we go horizontally to the right 1 and up 1. Another point there at 1, 1. So that is 1. Funnily enough, if you have a line and you have 2 points, that's enough to draw a line. If you draw your line through those 2 points, it's going to go through all the points. But it does ask us to fill in the table of values. So let's fill it in anyway, just to make sure we get all the marks. What we can do is maybe use that pattern recognition we had before. So we went down 2 to go from 0 to 1. So we're going to go down 2 again. So from there to there, we go down 2. So here we'll be at -1. If you're not so comfortable with doing that, just sub it in and work it out using algebra skills. But then we go down 2 again, so we're at -3. And if we're going the other way, we must be going the other way, if you know what I mean. So going this way, we're going down 2. So this way, we're going up the ladder, so to speak. We'd have to go up 2. So this would be 5. And then this would be 7. And this would be 9. Cool. So now we've got all our points. So we really have to plot them all, don't we, if we want to use this table of values properly. So let's just plot them all. So what, -3, 9. So we're going to the left 3 because it's negative. 1, 2, 3. We want to go up 9. So we're going up 2. Next one, -2. So we're going to the left 2, up 7. And that's that one. -1, 5. So -1, up to 5. So right 5. And we did those 2 points that when x is 0 and x is 1. So at x is 2, we've got -1. So to the right 2, down 1. And when x is 3, so to the right 3, -2. All right, so we can see all our points, they look very much like they're going to make a line. If you're drawing this on a piece of paper, best to use a ruler. On a computer, you can use something like this. Ooh, but it's not quite working for me, is it? Can I just straighten it up? It doesn't really want to do it, does it? Well, there we go. That looks pretty good. Something like that. As with by hand, sometimes it's hard to do it completely perfect. Okay, Now, we've done pretty well. The final thing we're asked to do is identify the X and Y intercepts from this graph. Let's just change colors for that. The Y-intercept is where the graph hits the Y-axis. That is this point here, Y-intercept. And that always happens when X is 0. The point there is, well, X is 0 and Y is positive 3. So the coordinate is 0, 3. As for the X-intercept, it looks like it hits in between 2 points. So it might be a decimal value. If we want to get this X-intercept algebraically, so I've identified it there, I've drawn it on a graph, and maybe that's all you'd be asked to do. You might be asked to give the coordinate, right? So if I want to do that, all I need to do is take my rule, y equals minus 2x plus 3. And in a similar way to how the y-intercept is always when x equals 0, the x-intercept is always when y equals 0. So if I make y 0, substitute in 0 there, if I rearrange this for x, I will get the x-intercept. So to do that, we've got 0 equals minus 2x plus 3. I need to get x by itself. First thing I might do is bring this 3 over to that side. If I bring it over to that side, the way I'd be doing that is I would be taking 3 away from both sides. If I did that, it would get rid of the 3 on this side. So I'll do that, and I get minus 3 equals minus 2x. So what I've done there is I've subtracted 3 from both sides. Minus 3 from both sides. Then, so I've got minus 3 equals minus 2x. I'm just going to rewrite that. Equals minus 2x. To get x by itself, I could divide both sides. Divide by 2. So if I do that, I'd get minus 3 on 2 equals minus x. And then finally, I could just times by negative 1. So you're just changing the signs of both sides. They're both negative, so then they're also the same. If they're both negative, if they're both negative, you can just make them both positive. Just changing the signs by timesing everything by minus 1. So our x-intercept is at 3 on 2. So if we want to write that as a coordinate, you might write it as 3 on 2 comma 0. X-intercept's always going to have x-intercept. The y value of the coordinate will be 0, which that's the same as 3 on 2 is the same as 1.50. And that looks, about where it would be on the graph from our somewhat rough drawing. Right, that is it for today. Thanks for watching.